All right, welcome to the video of 7.3. Great stuff today. Great stuff. We're talking about similar triangles. All right. Yes, not yesterday, well, maybe yesterday, but 7.2 was talking about similar polygons. All right. Today, we're just kind of focusing in on triangles, how we can prove when two triangles are similar to each other. All right. Now, let's say I have a triangle like this, a triangle like this. That's not, there we go. All right. Now, if you look at these two triangles, obviously they're not congruent. The one on the right is a lot bigger. Well, it's a little bit bigger than the left one. All right. But what we can prove is that they are similar. All right. But we can't just assume that because they look similar that they are similar. That's why we have these three postulates. These are ways we can prove that triangles are similar. First one is angle, angle. If I can look at this triangle, figure out this angle is the same as this angle, and this angle is the same as this angle, that proves that those two triangles would have to be similar. All right. Now, next one, side, side, side. That's just saying if I can prove this side is proportional to this side is proportional to this side, and this side is proportional to this side. If I can prove that, that means that those two triangles would be similar. All right, so what we will have to do, and we'll actually end up doing an example of this in a minute or two, you would have to set up proportions, figure out if those two triangles are similar or not. Then the last one, if I can prove that this side and this side are similar to each other, this side and this side are similar to each other, and also the angle between them are the same, that means that those two triangles would be similar. All right, so those are the three ways we are talking about today of how we can prove two triangles are similar. Those three postulates. Then also, these three properties, reflexive, symmetric, and transitive property, all three of those apply to similar triangles as well. All right, so we are going to do an example here. All right, we have two triangles. We're going to try to figure out, are these two triangles similar or not? So what we're going to do is we're going to set up a proportion. So I'm going to go 13 over 21. And then I'm going to figure out 9 over 12. And then 14 over 20. All right, notice how when I set these three ratios up, I'm putting the triangle on the left, that measurement on the top, and the triangle on the right side, putting those measurements on the bottom. All right, so that's where I'm getting all those numbers. All right, now, if these two triangles are similar, that means all three of these ratios would have to be the same. All right, so if I were to type these into my calculator, 13 divided by 21, rounded would give you 0.62. All right, this will give you 0.75. This will give you 0.7. All right, now if you look, these three are not the same. So what that means, these two triangles are not similar. It's too bad. They look similar, but they are not. We just proved why. All right, if they are similar, those sides have to be proportional to each other. All right, so like the rest, that's an example using side, side, side. Well, this is an example using side, angle, side. You would basically do the same thing for those two sides, but those angles would have to be the same. All right, so, and then we have a couple more examples, but we're going to move on to this bottom part. All right, so we have to identify, are these two triangles similar or not? All right, the two triangles we have is EHJ is similar to triangle EFD. All right, and I'm just going to kind of set up how you would solve this, and then I want to actually do it, but I'm going to just show you how to do it. All right, so since we know these two triangles are similar, that means I'm just going to set up a proportion. I'm going to go 6 divided by 12. This smaller triangle over this bigger triangle. 6 divided by 12 is going to be equal to x plus 5 over x plus 14. I just added those 5 and 9 to get that 14. All right, and then you just solve for x. Thanks.